Ceres, dwarf planet.
Ceres, minor planet designation 1. Ceres is the only dwarf planet in the inner solar system and the largest asteroid. It is a rock ice body 950 km in diameter and the smallest identified dwarf planet. It contains about one-third of the mass of the asteroid belt. Discovered on January 1, 1801 by Giuseppe Piazzi, it was the first asteroid to be identified, though it was classified as a planet at the time. It is named after Ceres, the Roman goddess of growing plants, the harvest, and motherly love. The Cererian surface is probably a mixture of water ice and various hydrated minerals such as carbonates and clays. It appears to be differentiated into a rocky core and icy mantle, and may harbor an ocean of liquid water under its surface. From Earth, the apparent magnitude of Ceres ranges from 6.7 to 9.3, and hence even at its brightest it is still too dim to be seen with the naked eye except under extremely dark skies. The unmanned Dawn spacecraft, launched on September 27, 2007 by NASA, is expected to be the first to explore Ceres after its scheduled arrival there in 2015. The spacecraft left asteroid 4 Vesta about September 5, 2012, which it had been orbiting since July 2011.
Discovery.
The idea that an undiscovered planet could exist between the orbits of Mars and Jupiter was suggested by Johann Elard Bode in 1772. Previously, in 1596, Kepler had already noticed the gap between Mars and Jupiter. Bode's considerations were based on the Titius-Bode law, a now discredited hypothesis which had been first proposed by Johann Daniel Titius in 1766, observing that there was a regular pattern in the semi-major axes of the orbits of known planets marred only by the large gap between Mars and Jupiter. The pattern predicted that the missing planet ought to have an orbit with a semi-major axis near 2.8 AU. William Herschel's discovery of Uranus in 1781 near the predicted distance for the next body beyond Saturn increased faith in the law of Titius and Bode, and in 1800, they sent requests to 24 experienced astronomers, asking that they combine their efforts and begin a methodical search for the expected planet. The group was headed by Franz Xaver von Zach, editor of the Monatliche Correspondence. While they did not discover Ceres, they later found several large asteroids. One of the astronomers selected for the search was Giuseppe Piazzi at the Academy of Palermo, Sicily. Before receiving his invitation to join the group, Giuseppe Piazzi discovered Ceres on January 1, 1801. He was searching for the 87th of the catalogue of the zodiacal stars of Mr. Locale, but found that it was preceded by another. Instead of a star, Piazzi had found a moving star-like object, which he first thought was a comet. Piazzi observed Ceres a total of 24 times, the final time on February 11, 1801, when illness interrupted his observations. He announced his discovery on January 24, 1801 in his letters to only two fellow astronomers, his compatriot Barnaba Oriani of Milan and Bode of Berlin. He reported it as a comet, but since its movement is so slow and rather uniform, it has occurred to me several times that it might be something better than a comet. In April, Piazzi sent his complete observations to Oriani, Bode, and Jérôme Lalande in Paris. The information was published in the September 1801 issue of the Monatliche Correspondence. By this time, the apparent position of Ceres had changed mostly due to the Earth's orbital motion, and was too close to the Sun's glare for other astronomers to confirm Piazzi's observations. Toward the end of the year, Ceres should have been visible again, but after such a long time it was difficult to predict its exact position. To recover Ceres, Carl Friedrich Gauss, then 24 years old, developed an efficient method of orbit determination. In only a few weeks, he predicted the path of Ceres and sent his results to von Zach. On December 31, 1801, von Zach and Heinrich W. M. Olbers found Ceres near the predicted position and thus recovered it. The early observers were only able to calculate the size of Ceres to within about an order of magnitude. Herschel underestimated its size as 260 kilometers in 1802, while in 1811 Johann Hieronymus Schroeder overestimated it as 2,613 kilometers.
Name.
Piazzi originally suggested the name Ceres Ferdinandia for his discovery, after both the mythological figure Ceres, Roman goddess of agriculture, Italian Ceres, and King Ferdinand III of Sicily. Ferdinandia was not acceptable to other nations of the world and was thus dropped. Ceres was also called Hera for a short time in Germany. In Greece, it is called Demeter Demetra, after the Greek equivalent of the Roman goddess Ceres. In English, that name is used for the asteroid 1108 Demeter. The adjectival form of the name is Cererian, derived from the Latin genitive Cereris. The old astronomical symbol of Ceres is a sickle, similar to Venus's symbol, but with a gap in the upper circle and with a variant under the influence of the initial C.
Right, there's Comet ISON for you. Yeah? Don't believe me? I'm going to backtrack this video and I'm going to show you ISON slowly turning into a comet. Or quickly. There you go. Wow, that's really strange. Because using this camera on that image, I shit you not, there you go, look, I pull out further, it becomes symmetrical lights. I zoom in with the camera. Oh look. Now that just shows you how light filtering can change a complete thing. Out. There. There you go. That just goes to show you, doesn't it? NASA's using light filtering to blot out the actual image. But I now zoom in. It goes back. I zoom out. Oh, look at that. I'm just going to check to see if I've got my light on. Yeah, so there you go, there's Comet ISON, and that just basically proves how NASA blares out and makes it look like a comet. There you go, I'm going in. This video is a still picture. There you go, we've got a comet, pull out. We have ISON, the real ISON. I zoom back in, all I'm doing is putting the camera forward and back. There you go, comet. Not a comet. There you go, Dark Sky Watcher, 74. There's a tree and light moment for you. Right, excuse the shoddy camera work. Right, 29th of August 2019. Says the 10th planet. Supposed to be sitting between Mars and Jupiter, roughly where the asteroid belt is. Now it's supposed to be a rogue orbit coming in and out of our solar system. It was supposed to have slingshot out. Let me show you where it's not slingshotting out. Let me put a year in fast forward. Now you know what? I'll make it 2 years just to make it positive. Tell you what, I'll just keep going. Because a rogue planet can't put itself in orbit. If a rogue planet that's supposed to slingshot out of our system like ISON is, why have JPL put it in an orbit? I'll just keep going. You know, 2016, it's still in orbit. It's not slingshotting out, it's saying it's still here. Well, ISON is supposed to get here by what was it, December 13th. Okay, so let's stop that. Right, so December 13th, as you can see, it says Mars and Earth are all aligned, not with the Sun, but I've got a feeling they're aligned with the comet path, craft path. In a minute I'll show you a cleanup of ISON, but believe me, let's have a look, shall we? Right, comet, you ready? Here we go, using a darkening tool, that's all, just to darken the bright light. Watch this. You tell me this is a comet. All he's doing is taking out the light. Yep. So all he's doing is removing the light. Now what is it you think you're seeing there? Yeah? Putting the light back in, you're getting a comet. This is Hubble's own pictures. Right? Or the other one, I don't know what the other one's name is. Celestron or something like that. But anyway, here you go. This is NASA's own pictures of this of the comet. What he's doing is using that darkening tool there and turning that. What the hell?